do today. We're going to finish the lecture first on stoichiometry, so we can be done with that. That's the end of the lecture. We've got like 6, 7 slides left. That's it. And then you have all the information that you need. The precipitation lab that I told you I really would like you to have done, the predicting stuff, that's going to be open in the main lab. It takes about 5 minutes to do, so you can just see how your predictions went. Like I said, that lab is, if you want to do it, great. If you don't, that's okay. And then we've got a teddy bear stoichiometry that you should have picked up right here. And that's sort of with what we're doing. Again, it's one that if you want to do it, great. It'll help you. If you don't, that's okay too. But the other one that you picked up, Lab 5.1, the green is your procedure, and the white is the paper that you need to hand in to me. You need to have that pre-lab done by next time. Okay? We're going to do that lab. That is a required lab. So make sure you're ready to go on that. Yes?
This one, not the Teddy Graham one?
Right. The Teddy Graham one is one that we're going to do if you'd like to. Okay?
This one is required.
But the other one is required. Okay? I do have the Teddy Graham stuff so that we can do the Teddy Graham s'mores after. So, okay? So that's what's going on today. So we're going to go right into lecture, which is here. This is where we should be, hopefully. Remember I told you I did one with you last time with the limiting and the excess. We're going to do another one so that we can have more practice, several actually, so we can have more practice and do what we need to. It's nice when they give it to you in moles. So on this one right here, we can just right away say 3.22 moles of aluminum versus 4.96 moles of HBr. Now it's a 2 to 6 ratio, or a 1 to 3 ratio if you reduce it down. So for basically every 1 aluminum I need 3 bromines. Well, if I look at that, if I go 3 times what aluminum is, I'm going to be up in 9, right? So I'm just looking at it and seeing which one am I going to run out of first. It's already in moles, so I can do that. It looks like I'm going to run out of the HBr, right? Because if you look at this, if I reduce this real quick on a fraction, it would be 1 to 3, right? Okay, so if I do that, then I would have to times that aluminum by 3, which would be about 9, a little over 9, and I only have 4. So this HBr, so HBr is going to be my limiting. That means that Al is excess. So the first thing that you want to do is make sure that you can identify your excess and your limiting. Once you've done that, then you can figure out all the rest. So what is my limiting reactant? HBr. And I can go ahead and start with 4.96 moles of HBr. Now, what am I trying to get to here? How many moles of H2 are formed? This is just a simple conversion. I don't have to do a whole heck of a lot. I'm going to be using the 6 and the 3. So I'm going to, on the bottom, put 6 moles HBr, and on the top I'll put 3 moles of H2. Moles of HBr would go out, and I'm done. All I have to do is times it by 3, divide it by 6, and I've got moles of H2, which is what they wanted. So somebody throw a calculator at that, and let's see what we can get. How many significant figures should we report? 3. Good. Okay. So put that 3. Let's see what we get for 3 significant figures. If you haven't got a calculator, there's some up here. I still need to get batteries for my TIs. I'll try and have that for next week. Okay? So that we can save Avogadro's number in them. And then when you get on the test, it's a lot easier. Okay? So what have we got? We're basically taking that and dividing it by 2. So 248, is that right? 2.48? Okay, on the bottom one, for the reactant in excess, how many moles are left over at the end of the reaction? So I'm actually going to write it above because it gets a little small down at the bottom and my pen doesn't write really well. Again, you want to start with what your limiting is, your 4.96 moles of HBr, and you want to change it into moles of aluminum. So we want to go and use this and this time. So we're going to use the 6 moles of HBr to 2 moles of Al. And they just want moles, so I don't even have to go to grams. Okay, moles of HBr go out. This time I'm dividing it by 3 basically. So 4.96 times by 2 divided by 6 is basically dividing it by 3. And we get moles of aluminum that we used. It will be 1 point something. What is it? So let me grab a calculator. We should all be trying to punch this into our calculators as we're doing this, so you make sure you understand how to get the right answers. Yes? 1.65. This is how much we used. That's not how much that's left. You got to be careful there. That will always be one of the distractor answers. Okay? What you need to do to find out how much is left over, how much is in excess, is take that 3.22 minus the 1.65 to get your answer of leftover or excess aluminum moles. Okay, so if we subtract those two, we're going to get 1 point something. What do we get? Yeah. 1.57. And that would be my answer. So be careful on ones like that. They're not asking how much you use, but how much is left over. And that's really important when you're in industry, because you don't want to have a lot of excess left over that hasn't been reacted, because that's money down the drain. Okay? You want to be able to spend that. All right, so let's go on to the next one, maybe. Okay? So consider the following reaction. We've got silicon and nitrogen making silicon, trisilicon tetranitride. When I have 21.44 moles react with 17.62 moles, how many moles of this can I make? So I'm going to give you a second, and this is just like the one we just did. I want you to see if you can do it on your own. It's just like the one we just did. So see what you can do, figure out which one's limiting. Now this one's a little bit closer, right? It's a little bit closer, so you might have to convert one into the other. You might have to do that either taking 21.44 and converting it into moles of nitrogen, or the 17.62 converted into moles of silicon, because they're so close. 3 to 2 is really hard to see. So something like that, just to see what they compare to each other. You didn't have to take the first one like I did. I'm just doing it because I know some of you are looking at me like I have no idea what to do. So this tells me I don't need as many moles of nitrogen as what I have. So silicon is my limiting. So go ahead and go from there. Okay? And I've actually helped you solve the last one too. Oops. Uh-oh. Okay, don't look up until you've got it ready, and I'm just going to do it slow. Okay, how do we do? Because we already calculated that nitrogen moles up at top, which is what we would do on C. It's sort of like the luck of the draw on which one you choose to convert to the other. Okay? So once you've converted one to the other, since I know that nitrogen is the excess, all I had to do is subtract the two to find out how much was left over. Okay, any questions on that? We okay? Yes. C is what I did at the top in the right-hand corner to find out how many moles of nitrogen was used, and then I subtracted in the blue right there, right above C, what I had minus what I used to get the excess. So right here, I'd already done that calculation. That was this right here. And then this is what I had to start with. So I just subtracted them. Okay? All right, let's go on to the next one, see what we can do with the next one. So on this one, we're also given moles. Again, I'm going to give you some time to see if you can do it on your own. I'm not going to tell you what's what this time. I'm going to let you. I will go ahead and put these underneath so you can sort of see. And like I said, this is what I do. It helps me. If it helps you, great. Just right underneath each other. So it's a basically 1-to-2 ratio. So I reduce it so I can really quickly in my mind see is it a 1-to-2 ratio. If it's not, which one do I have more of? So the other one was a 2-to-3, which was harder. That's why I did that conversion off to the side, because 2-to-3 is harder to see. 1-to-2 isn't, right? So if I have a 1-to-2 here, I need for every 1 calcium chloride, I need 2 potassium iodides. So do I have that? If I don't, then the potassium iodide is limiting. Does that make sense? So do I have twice 0.56 right here? I don't. So this becomes my limiting. Then I work with that. So this was a 2-to-4, right? So I just reduced it. So it's a 1-to-2, right? Because both of them can be divided by 2. So just in my head I do that. I'm not going to use that in my equation, but I just want to know the ratio to each other. So for every one of these I need 2 of these. It's easier than to say every 2 of these I need 4, because I can't do that in my head.
How do you do it like 0.56 and 0.66? Oh, okay.
I just wrote them up in. Yeah. Uh-huh. Okay, so go with that for a minute, see what you can do with it. Want to make sure you can do it. If you're needing help on an individual basis, just raise your hand and I'll come help. If you get stuck, you can look up here. So start always with your limiting. So we found out our limiting was Ki because it's 1:2 ratio. So twice copper chloride would be 1 point something. I don't have 1 point something. That's why Ki is my limiting. So I always start with my limiting. Then I'm trying to get from Ki to I2. So I put the 4 moles of Ki on the bottom. And I put 1 mole of I2 on the top. Moles of Ki go out. I would take that and divide it by 2, or divide it by 4, and it's 0.16, thank you, moles of I2. That's one answer. Then this bottom one here, how much do you have in excess? I still am going to start with my 0.64 moles of Ki because I want to know how much of the calcium chloride I used. So this time I'm going to be using this and this to be able to go back and forth. So on the bottom I want to get rid of Ki, so I put 4 moles Ki, and on the top I want to go to copper chloride, so I put 2 moles of copper chloride. Moles of Ki go out. I would take this, times it by 2, divide it by 4, which is basically dividing it in half. I get 0.32 moles of copper chloride that I have used. I have 0.56 moles of copper chloride that I started with. I'm just going to subtract those two, and I get 0.24 moles of copper chloride in excess. Okay, can you see how I went? It's right above right by the life. You see the? Thank you. Yes. So limiting is the one I'm going to run out of. Okay. So up here we had a 2:4 ratio. Okay. Both of those can be divided by 2. So to make life easier on me, I want to say, okay, for every one of these, I need 2 of those. So if I take and times what copper is by 2, it would be 1 point something, right? I only have 0.64 here. I don't have enough. So this one is the one I'm going to run out of first. So I don't have enough hot dog buns. So this one's the one I'm going to run out. That makes it my limiting. Okay? Did that make sense? The last one we did was a 2:3 ratio. And so I can't really see in my head 2:3 because the one that needed 3 was more, but I didn't know if it was how much more. So if we go back to this one right here that we were doing, I can't see in my head. See, the 3 had more, but I didn't know if it was enough more. That's why I did this over here, where I converted this first one into the second one to see if it used all of it or did I need more than whatever. I ended up with a lower number than what was here. That means my silicon was my limiting. Okay? So if you need to, if you can't see it in your mind's eye, you can convert one of them into the other and see which one's bigger, which one's smaller. That can tell you right there. I'm just trying to circumvent that step. Okay? But you can do that. No problems. And you'll get the right answer every time. Just pick the lower one, the one that has the least, for your limiting. Okay? All right, let's go forward and do another one. Okay, again, try and do it on your own. I'll put it up in a minute. If you're stuck and you need some help, let me know. This time, I'm not even going to write underneath for you. I'm going to make you do it all. For a few minutes anyway. Struggle for a few minutes. If you need help. Freezing? That north wind gets really cold. I'm going to shut this door. Yes, sir. Okay, what I like to do is I like to put this number right underneath each of them. So go ahead and put those numbers that belong right under each of them. And I'm sorry that the subscripts didn't work on this one very well. For some reason, when I copied and pasted, they went away. So I don't know why. I'll be fixing them. So it says for every one of the, all right, so every 4 of these, I need 11 of these. So do I have, for every 4 of these, do I have 11 of these? No, because I have a lot less, right? So this is my limiting reagent. I don't have to do any calculations. I just know it says I need more of this than this, and I don't have it. So this is my limiting. So I'd say O2 is my limiting. And then I start with that 5.44 moles and then convert. You okay to try? Good. No? Okay. Okay, get working on them, guys. Yes.
Would I snug it like that?
Yep.
Okay. And then I'd put,
What are you trying to get to?
so I'd put 8.
Mm-hmm. Yep. Yes?
If you send Peony photo to you to check out.
Okay. Uh-huh. Okay, again, don't look up until you feel like you're stuck or you're done and you want to check it. Okay, how are we feeling about this so far? Did we get the right answer? Do we have any questions about where things came from? Now, remember, they can ask you how many grams are left. All you need to do is use your mole map and go from grams to mole, or from moles to grams. So this is the simple part right here with just moles. If they start with grams, you got to put it in moles. You cannot use the balanced equation until you're in moles. Okay, so that's really important that you need to make sure you're converting back and forth. Okay. And there's a big mole map for you. Okay. So you need to be able to go back and forth. Yes. And there is a mole map on every single wall. So let's go ahead and go to the next one. We're now going into percent yields. An important thing about percent yields, this is a big thing that they worry about in industry. If you have an 80% yield, you're doing well. If you do below an 80% yield, then you might be in jeopardy of losing your job. Because they want good yields. If I'm putting all this chemical and this money in to make this product, I want to have a decent yield. So basically, percent yield is just actual divided by theoretical times 100. In other words, it's like finding your percent on a test. Okay? The theoretical yield is what we've been doing. We've been figuring out what we could have got. Okay? The actual yield is what I actually get in lab. They're not the same. Now, if I end up with above 100% yield, something went wrong. And you're probably going to also be in jeopardy of losing your job. Okay, so the equation is right here. Okay, an actual yield of a reaction is this. So that's my score on the test. While the calculated yield was this, what's the percentage yield? This is simple, right? 11.74 divided by 16.09. We're going to times it by 100, and we find out what our percent yield is. This should be simple. As long as you know how to calculate your percent on a test, you know how to do this. Now, a lot of times they don't give you the theoretical yield. You have to figure it out, like what we've been doing before. And then they'll tell you, this was my yield. What's my percent? So you're going to have to figure out this number right here by using that stoichiometry. What do we get for percent yield? Are we going to get fired, or are we okay? Yeah.
I got 72.96.
Ooh. So I'm under review, right? Yep. Okay, so let's go to the next one. A student uses stoichiometry to calculate the predicted yield of CO2 as, here's my theoretical. But I only get that much. What was the percent yield? So set it up. Remember, it's got to be under 100%. So if you did it wrong, you'll understand real quickly what you did wrong. Biggest goes on the bottom. Always. Theoretical should always be the biggest. If you end up with the biggest on top, you really screwed up. Because you can't get over 100% on a test, right? For normal tests, especially at college. There's no extra credit. Go ahead and do the next one also, see if you can get it set up. What do we get on this one? One more time. 95%. Okay, we usually take it to 2 after the decimal. Can you give me 2 after? Okay. So on percent, you usually go 2 after the decimal, just as a constant on percent. Okay, now on this next one, we've got a little bit of an issue here, right? They didn't give us the numbers we need. They said the reaction started with 384 of S6. So S6, I had 384 grams. And assume an unlimited supply of oxygen. So oxygen is my excess, so I don't need to worry about it. And I end up with a predicted yield of sulfur dioxide, SO2, of if only that much, 680 grams, were produced. So this is like what I was telling you. This one's going to take a little bit more oomph. First of all, I need to balance it. So balance the equation. What do I need to do to balance the equation? Well, put a 6 over here, right? And put a 6 right here. Be okay with that? Okay, now I've got to convert this to moles, then go from moles to moles, and then go from moles to grams. Okay, so this is like what we've been doing last time. So start with the 384 grams of S6. Now when it's a compound like this, what I do, just to save myself time, is I go 1 mole of S6, so we're going from grams to the center using the green arrow. I just go 6 times 32.065. That's just 6 up here. Okay, grams of S6. So I didn't times it out because I'm going to times it out in my calculator anyway, right? Then, at this point, I can go up into my reaction, and the 1 and the 6 here help me convert from one compound to another, but I have to be in moles first. So for every 1 mole of S6, I get 6 moles of SO2. So at this point right here, mole of S6 goes out. But now, in order to get to the last step, 1 mole of SO2 is going to go on the bottom, but I'm going to have to add up sulfur, 32.06, oxygen, 2 of them at 15.99, and get an answer here. Should be around 63-ish. 64.0. 058. Thank you. That's how many grams per mole there are of SO2. So here I'm going to put 64.058 grams of SO2. The moles cancel out. Now, remember when you go to do this, though, when you hit the divide sign, make sure the whole bottom's in parentheses to get to the end. You don't have to put ones in. Okay? So I'm just going to go 384 times 6 times 64.058, and then I'm going to divide it by parentheses 6 times 32.06, close my parentheses. Okay, let's see what answer we get. This is how much I could have produced. This is the maximum I could have produced. Okay, what do we get? 767, give me one more. 0.3? Okay, do I have a second on that? Awesome. So now all we have to do is do I now have figured out the total that I could have got on the test. Now I'm just going to take this number and divide it by this number and times it by 100 to get my percent yield. I ran out of room on the end, so sorry. So 680 divided by 767.3 times 100, what do we get? $80.6? 88.60? Okay, that was my percent yield. So a decent percent yield for industry. Okay, so can you see how this is all sort of intermixing with each other? As long as you know how to do stuff, you'll be okay. So grams to moles, like I said, the mole map is really important for your thing to remember that you need to have a balanced equation, and it has to be in moles before I use the balanced equation. Okay, then that was like the test total. That's the maximum I could get on the test. I only got this. So I'm finding my percent on the test. Take the 680, divide it by this, times it by 100, and I got this. Okay? All right. So now we're at the point where we've learned everything. There's nothing else new. It's study time. Test is next Friday. So today we've got the ability to, if you want to go back and do the drop lab and see how you did as far as predicting, great. If you want to do the stoichiometry lab, which is a lot more of what we've been doing, only with food, you can do that. Or you can work on your pre-lab, or you can work on your, hopefully you're done with your Learn Smarts, because I really hope, I emphasize that you needed to be done with those and working on your homeworks now. Okay? Time is yours. I'll have the stuff for the Teddy Bear Stoichiometry Lab up here in little cups. If you want to make your s'mores, you can. If you just want a little treat, you can do that too. Okay? So it's up to you.